Hello friends, welcome back to Secret of Electronics. In this tutorial, we will learn how to control a high power load using a microcontroller and an IGBT. This circuit shows how a microcontroller Raspberry Pi Pico W safely controls a high power 12-volt load using an optocoupler and an IGBT. GPIO 0 from the Pico drives the LED inside the PC817 optocoupler through resistor R4 220 ohm, which limits LED current and protects the GPIO pin. When GPIO 0 goes high, then the optocoupler's internal LED turns on, activating its phototransistor. This provides electrical isolation between the low voltage microcontroller side and the high voltage power side. On the output side of the optocoupler, the phototransistor pulls the gate drive node high via the plus 12-volt supply. Resistor R2 1 kilo ohm limits the gate current into the IGBT, while resistor R3 10 kilo ohm acts as a pull-down to ensure the IGBT gate is discharged and off when the optocoupler is inactive. When the IGBT gate is driven high, Q1 turns on and completes the ground path for the 12-volt load connected at J1, allowing current to flow from plus 12-volt through the load to ground. When GPIO 0 is low, then the optocoupler turns off, the gate is pulled to ground by R3, the IGBT switches off, and the load is disconnected. This MicroPython program demonstrates basic digital output control using a microcontroller GPIO pin. First, the pin class is imported from the machine module to access the microcontroller's hardware pins, and the time module is imported to create delays. GPIO pin 0 is then configured as an output using pin 0 pin.out and assigned to the variable LED inside the while true loop. The program runs continuously, setting LED.value1 drives GPIO 0 to a logic high level, turning the connected LED on. The time.sleep1 function pauses execution for 1 second. Next, LED.value0 sets the pin low, turning the LED off, followed by another 1 second delay. This cycle repeats independently, causing the LED to blink with a 1 second on and 1 second off pattern. Now connect the Raspberry Pi Pico W board to your PC or laptop using a USB cable. After connecting, open the Thony IDE. Once Thony opens, you will see the MicroPython version in the shell section. This indicates that the Raspberry Pi Pico W board is successfully connected to the PC or laptop. Now copy and paste the MicroPython code into the Thony IDE, which you can copy from the link provided in the description. After pasting, save the code file as a main.py on the Raspberry Pi Pico W board. Finally, disconnect the Raspberry Pi Pico W board from the PC or laptop. Now connect all the components according to the main circuit diagram discussed at the beginning of this tutorial. After connecting all the components, power the Raspberry Pi Pico W board using a 5V DC source by a USB cable and connect a 12V DC power supply to the IGBT circuit as shown in the circuit diagram. Once both power supplies are connected, you will see the high power 12V LED blinking with a 1 second delay. We can also control the brightness of this high power LED using PWM. If you want a tutorial on brightness control, let me know in the comment section and I will upload a complete tutorial. If you liked this tutorial, then do not forget to subscribe to our YouTube channel for more upcoming and interesting tutorials.